So is the screen is visible to you and I'm audible to you? Each and everyone, let me know. There any problem? Just a second. Got it. So we are live on YouTube also now. So good evening everyone. I welcome you all in this session of question discussion on wave, the chapter that we are currently moving with. So in this question discussion, some of the portion I have taken and rest of the portion we will deal in the further classes. Okay, further weekend classes. So firstly, what we are going to do, we will move according to the tradition that we have set. We firstly see the revision, the concept that we are going to use to solve the question that I have selected, and then one by one we will ask the questions. Okay. The level of question is obviously from basic to advanced, so that you can easily grasp the concept and learn how to apply the concept. Okay. So now let's just get started with it. So if I talk about in revision, what we can do. Revision if I talk about, so firstly we will understand what a wave is. So wave is a disturbance that travels from one medium to another medium. So wave here is a disturbance of energy or momentum. Okay. So this phenomena, the propagation of energy, propagation of momentum, and this could be anything. This energy could be a pressure energy, electric energy, magnetic energy, okay, potential difference, displacement. So the wave is itself the disturbance of energy and momentum. Okay. We know that there are two types of wave, two types of and wave. And what was that? First is the mechanical wave, and second one is the non-mechanical wave. Okay. So when the wave propagate, it requires medium. Now, those waves who require a medium to travel from one place to another place, or which require a medium to transfer that energy from one place to another place, that particular category of wave is termed as mechanical wave. Okay. That category of wave is this require medium to propagate. And this non-mechanical wave does not require any medium, does not require any medium. Now, what was the example of these waves? So mechanical wave generally are the sound wave. You can take the example of sound wave, wave inside the water, or wave pulse, you can say wave pulse on water surface. These are the two visible examples. Obviously, sound wave is not visible, but you can imagine it. Okay? Because it is the disturbance of pressure or density, okay, which travels from one place to another place. That pressure difference or temperature, that pressure difference or density difference, specifically the pressure difference, is decoded by your ears. That is why you are able to hear what I'm saying to you. Got it? So this require a medium. And what is that medium? The medium which is present between me and you, and that is air. Okay. So these wave require a medium. So those are mechanical wave. They are using the mechanical resources. Non-mechanical wave does not require any medium. So these waves is termed as EM wave, light wave, okay, IR wave, UV wave, ultraviolet. Okay. So these all you can categorize as the non-mechanical wave because this does not require any medium to propagate. Sun is generating UV rays or wave, you can say. So these UV rays travels from sun to earth without any medium inside between them. Because we know in this space there is nothing, although there are other interstitial bodies, I'm not considering them. To travel, for a wave to travel with the medium that is required, which is not present there. There is only vacuum. So that is why these wave does not require any medium to travel or propagate. Obviously, they are carrying energy with them. This energy could be in the form of light, in the form of heat. Okay. So these types of wave is termed as UV waves, sorry, non-mechanical waves. Okay. Now there is another type of also there is another type of wave which we can establish. Just a second. Types of wave based on the motion of particles and motion of wave. So if there are classified as two, this is longitudinal wave and the second one transverse wave. Got it? So these transverse wave are those in which the medium particle will travel, yeah, which oscillate perpendicular to the wave velocity. So I will draw it like this. So here the particle is oscillating to and fro, up and down, and wave is moving in this direction. But in longitudinal wave, particle move or oscillate along the wave direction, along the wave. And in transverse wave, it travels perpendicular to the wave. Okay. Now, after that, we have established what is in our syllabus, a simple harmonic progressive wave. Okay. This simple harmonic progressive wave, simple harmonic, and before that simple harmonic progressive wave, we have seen the traveling wave function. Traveling wave function. Let's say y is the displacement of that particular particle which is oscillating equals to ax plus minus bt. That we have established the relation. Okay. Because in a wave, if this is a wave I will consider for transverse wave, the wave is moving in this direction. So a wave is nothing but the collection of particles which are oscillating about their mean position. Okay. A wave is a collection of particles which oscillate about their mean position. Now, oscillation and SHM are the different case. SHM is the simplest case of oscillation we have seen in the SHM chapter. So these particles oscillating about their mean position, and we have collected so much of particle that's why we have got a pattern, and that pattern is termed as a wave. Got it? Now, it is not necessary that particle which is in wave execute SHM only. No, it is oscillating, but it is not a hi-fi rule that that particle should be in SHM. But if any displacement function, because the particle is displacing from their mean position, so if the displacement of this particle is in the form of f of ax plus minus bt, then we can say that this particular particle is a part of a wave which move according to this equation, because we need the position and we need the time to know the displacement of particular particle which is present in wave. Got it? So the general equation is del 2y by del x square equals to minus velocity times del 2, sorry, del 2y by del x square, del 2, sorry, del t square. Okay, this is the particular function of wave velocity. Let me correct myself. I have written it correct or not, just for to check purpose. Okay, do not go anywhere. I'll check it. Okay, so we have just need to replace this del 2y by del t square, del 2y by del x square. Okay, so this is the general equation of general differential equation. If any function is given to you, if it satisfies this equation, that function is termed as out to be what? A wave function. Now, based on the discussion, we can conclude that particle which is present in wave, which forms the wave, is oscillating about their mean position and do not shift, do not travel with wave. It just oscillate. If this oscillation is SHM, then that traveling wave is termed as simple harmonic progressive wave. And the equation of simple harmonic progressive wave, harmonic progressive wave, is given by y is equals to a sine omega t plus minus kx plus phi naught. Here in this equation, a is the amplitude, y is the displacement of a particle which execute SHM in a wave. Okay. Now, this you can say omega here is 2 pi f, which is the angular frequency, f is the linear frequency, k here is the wave number, which is given by 2 pi by lambda, and this phi naught is the initial phase. Initial phase. We have a detailed discussion on phase, what is phase and what is the important of it. So I'm going to rapidly cover it up. This omega t plus minus kx plus phi naught is the phase itself. So you can say phi is equals to omega t plus minus kx plus phi naught equals to phase. Okay. Now, so everything is decided by this phase. Got it? Now, this is the equation you need to remember. Now, here I will write two formula. Anyone, any kind of doubt if you have till now, you can ask. So if a wave is propagating in a medium, and let's say the transverse wave, the speed of transverse wave in string, and यहाँ से कैसे निकाल सकते हैं? Speed of wave, wave speed is denoted by v, particle speed is denoted by v. So wave speed v is given by coefficient of time divided by coefficient of x. Okay, this is the wave velocity. You are going to need this formula. Okay, speed of transverse wave in string. So we noted that any wave which is establishing in a medium depends on the elastic property of that medium and the inertial properties of that medium. Based on that, in string, the elastic property is denoted by the tension in the string, and the inertial property is denoted by the mass per unit length. This is the linear mass density. Linear mass density. Got it? Now, speed of transverse wave in any medium in spite of string. So this was on of given by gamma, sorry, not gamma, it is y upon mu. Y here is the Young's modulus of elasticity. Now same thing, in air or in gas, the wave that will be developed is longitudinal wave. Okay, so speed of longitudinal wave in gas. So there are two formula. First is the Newton formula, which is incorrect, and second one is the Laplace correction. Okay, so we are totally discussing about the Laplace correction. Why we will discuss the incorrect formula? So Laplace, given that the velocity or the speed of wave in gases is given by gamma p, p is the pressure, upon rho, rho is the density. Gamma is the adiabatic index of that wave. P is the pressure of that wave. P is the pressure of that medium. Okay, pressure that has been applied on this gas, and rho is the density. Got it? Now, based on these information, we will discuss the questions. Now, the very first question on your screen is, try to solve it, giving you strictly 1 minute to solve this. Very easy question. Okay, so this you can solve. Here, what is given to you? That y is equals to 1.5 sine 328 t minus 1.27 into x. Instead of this equation, I would like to write that you will use this equation. Sine 314t minus 1.57 into x. So this you will use, not this one. It is easy for you to calculate with this equation. Now try to calculate. So we know that we have a general wave equation A sine omega t minus kx. If you compare this A, you will get the value of amplitude, which is 1.5 centimeter. Now, if you compare the omega, so omega is 314 radian per second. But we want to know the frequency. Frequency is F. Omega we can write 2 pi F, and the value of pi is 3.14 approximately into F. 314. Now this and this will cancel 100 times. So frequency here will be 50 hertz. Anyone got this answer? F is equals to 50 hertz. Now if you compare this K is equals to 1.57. You will not take this minus, only K, 1.57. So K here, if you will see, you can write 2 pi by lambda. It is 1.57. Again, 3.14 lambda 1.57. This will become 2. So lambda here is 4 centimeter. This is the wavelength. Now, if you talk about the time period is nothing but 1 upon f or 2 pi by omega. Whatever the formula is easy for you, you can use. So 1 upon f is 1 upon 50. You can write it 0.02 second. Anyone? Any kind of doubt in this question? This is the very basic question you can expect from this chapter way. So if anyone has any kind of doubt, you can ask. Okay. Now I'm moving on to the next one. Write down the equation of a progressive wave traveling along the negative x-axis and having an amplitude of 0.21 meter, a frequency of 225 hertz, and a wavelength of zero point 0.6 meter. Now write down the equation. Very simple. What you can do? We know that y is given by a sine omega t plus minus kx plus phi. So phi we will not take here because we can assume that phi is 0. Okay? For the simplification purpose. If you have to take plus or minus, who is going to tell me that what should I take? Plus or minus? This equation, this progressive wave is traveling along negative x-axis. So we have two options. Either we should write it like this, omega t minus kx, or we can write it as like a sine omega t plus kx. Now, which one is the correct one? This one or two? Tell me. Tell me in the chat box. Each and everyone. JNV Ramnagar, Bhavnagar student. Tell me. Come on, guys, you can tell it. I have told you in the classes more than 2 to 3 times that what should we have to consider. Anyone? Okay. So JNV Ramnagar is saying we have to write 2. No response from JNV Bhavnagar. What is the issue with you guys? There are so many students from JNV Bhavnagar. Not a single one has been answered. It's very simple. Look, if a wave traveling in negative x, so both omega t and kx will be positive. Both positive. And if it is traveling in positive x, they both will be negative. Okay. Sorry. If they are traveling in positive x, they are of opposite sign. Okay. So both when negative x, both opposite when they are positive x. So the wave is traveling in negative x direction. So we should consider option number 2. Very good, student of JNV Ramnagar. Very good. It seems that you are paying attention to the regular classes also. It's very good. A sine omega t plus kx. Now, all the values is given to you. You just have to write. You can write this omega as 2 pi f into t plus k को you can write 2 pi by lambda into x. Now the amplitude is given to you 0.21. Amplitude is this a 0.21 meter. Sine 2 pi. What is the value of f? F is given to us 225 into t plus 2 pi by lambda is given to us zero 0.6 into x. So you can classify it as 0.21 sine. It will become 450 pi t. Okay. Plus this will cancel out this. It will become 0.3. So 10 will go upside. So it will become 10 pi by dx. So this is the general equation of the wave which is traveling with this much of amplitude with this particular frequency and this particular wavelength in negative x direction. Okay, so I hope everyone getting this. Now I'm moving on to the next question. This the formula that I have already told you. Try to solve this question. The equation of wave is given by y is equals to 10 raised to the power minus 2 sine 2 pi 160t minus 0.5x plus pi by 4. So where x and y are in meter and time in second, so speed of the wave is. And this question is latest question of JEE 2023. Look how simple question is giving you 4 marks if you are able to solve it. Now try to solve it. I am giving you 1 minute. After 1 minute, I will start solving it. Okay. These types of question of your time saver questions. You will save your time in this question and apply in a little bit complex question in the examination. And that is termed as time management. That is how you are going to manage your time in the examination. So So I'll suggest you that always use a timer when you are practicing question. Always use a timer. Okay. Set a timer for 50 minutes or 30 minutes, whichever suits you. And in 30 minutes, try to solve at least 10 questions. In 50 minutes, try to solve at least 20 questions or 25 questions. Okay. And if you are not able to solve that, so keep increasing your pace, your speed, and one day you will definitely achieve it. So 1 minute is over. I'm start solving it. So the equation is given y is equals to 10 raised to the power minus 2. What I will do, I will multiply this 2 pi inside the argument which is written. So this will become 2 pi into, which play no difference in that. Okay, if you keep the 2 pi outside, that means no difference in that. Okay, I'll do that in the same way. 160t minus 0.5x plus pi by 4. Okay. So I have told you that velocity, the speed of wave, is given by coefficient of time divided by coefficient of x. This one, this 0.5. So it is 160 by 5. 5 3 is a 15. 5 2 is a 10. 0. So 320 meter per second, but it is meter per second. Now you have to convert it into kilometer per hour. So to convert meter per second, take a note of it, to kilometer per hour. What you will do? You have to multiply whatever is given to you in meter per second by 5 by 18. Okay. And to do the reverse, if you want to convert the kilometer per hour into meter per second, so you have to multiply the inverse of it, 18 by 5. Now 5 by 18 you will multiply here. So what you will get? 9, 160, 800 by 9 kilometer per hour. Okay. If you divide it, it will definitely a lower value than this 320. Got it? Because how do we able to do this? Just a second, I'll check it. Meter per second to kilometer per hour. Now 1 meter has 1 by 1000 kilometer. 1 second has 1 by 3600 hour. So it will be 3600 divided by 1000 kilometer per hour, which is giving you 5 by 18. So I've just reverse it. You have to reverse it. Okay. To convert meter per second to kilometer per hour, you need to multiply by 18 by 5. So if you multiply here with 18 by 5, you will get 5 6 is 30, 5 4 the 20, and if you multiply this 64 and 18, 2 3 6 4 6 2 5 11. So it is 1152. Very good. 1152 kilometer per hour. So your supersonic jet, if you have ever heard about it, supersonic jet, supersonic missile. How many of you heard about it? Generally, we will listen to these types of word in the newspaper or the television broadcasting. So supersonic means the speed which is greater than the speed of sound, which means that particular missile or particular jet is moving greater than this velocity, which is 1152 kilometer per hour. Okay, so that is the meaning of that supersonic term. And there is another term also, hypersonic, which is greater than, very greater than the speed of sound. Now, the same way, the question, now you will also solve it right now. Try to solve it, and but in this, the answer is in only meter per second. But you have to focus here. This x is in centimeter, t in second. What is the answer? Same year question in the evening shift. 5 sine 60 plus 0.003x. Velocity of wave is nothing but omega by k. Omega is this coefficient of time, 6, coefficient of x, 0.003. So it will become 6000 divided by 3 multiplied by 10 raised to the power minus 2. Why it is 10 raised to the power minus 2? Because this 6000 is in meter, sorry, centimeter. So we need to convert it into meter. So this 2 power will eat up them and it will become 20. So it is 20 meter per second. Have you got this answer? Anyone? Any kind of doubt in this question? You are free to ask. Now the next question is this. A sine wave is traveling in a medium. The minimum distance between two particles always having the same speed is, this question we need to tackle. Got it? Now this question does not require, specifically does not require any mathematical calculation. It a question of imagination. Okay. You have to visualize the sine wave and do what is needed. Okay. But I will do it in the mathematical way also and in the visualizing. So firstly, we will start with the visualization. So visualize a sine wave, or you can draw it in your pen and paper, whatever you have taken. And if anyone is able to find out the answer of it, please write it in the comment box. So a sine wave is usually looks like this. Okay, this is a sine wave. But it is traveling in a medium. So this is y and let's say this is x. Now, if you have focused on your regular class, I have tell you a formula that Vp, velocity of particle, is minus of slope multiply velocity of wave. Got it? So if the wave is traveling in this direction, you can see, which means if I use this formula and consider this particle, this one, the slope here is negative, which means this particle is moving downside according to this relation. Okay. But if the wave is traveling opposite side, this particle is moving upside. Okay. But I have assumed that wave is moving from negative x to positive x. So this particle has a downward velocity. What about this particle? Here the slope is positive. So So this particle is moving up. If I talk about this, here the slope is 0, which means this particle is at rest, which is all obviously because it is at the extreme position of it. Got it? So which one particle always having the same speed? Same speed. Which one? So let me tell you one thing. We have denoted the displacement of any particle y1 is a sine omega t plus, sorry, minus kx. And the another particle we have assumed a1 sine omega t this particular time kx1 at different position. Okay. So we can say here to the particle to have the same speed, this, if I differentiate this, the particle velocity will be dy by dt. So it will become a omega cos omega t minus kx. And this one also a omega a1 omega cos omega t plus kx minus kx. Plus phi you can also add if there is a phase difference. Now, if you compare to have the same velocity, that particular particles, that two particles must have the same amplitude at a particular time. Got it? So suppose if I taken the snapshot of this wave, I have taken a photo and I am focusing on this particle and this in the same way, I draw a line. So this particle is having also the same amplitude. Okay. But for simplicity, what we will assume? We will assume these two particles. These two particles have same velocity. After this, they will go down, definitely. Okay. But here, if you focus that we are not interested in velocity, we are interested in speed. So whatever, if they are moving in opposite way, that will also okay. So in the same way, if this particle is moving down, so at this particular peak, this particle is moving up with the same velocity. And they have same amplitude also, if I just forgot the sign. Which means that these two particles which are out of phase, there is a phase difference of pi here. Okay. This is up, this is down. So the wave is have moved pi angle. So these two particles, this particle 1 and this particle 2 has the same velocity, same speed, not velocity. The direction of their motion is opposite. Okay. And these two particles are the closest one. इसके अलावा और कोई दो पार्टिकल नहीं हो सकते that they are moving in the same speed. ठीक है? You can say this particle भी तो हो सकता है, this one. Okay, so you have to take the same one in the downside, this one. But it is easy for us to measure the distance from the peak. So that is why I have assumed this. Okay. Now we know that to complete one cycle, the wave has to travel lambda by 2. Sorry, lambda. Okay. So this particular distance we can say is lambda by 4. This is lambda by 4. That is why this distance will become lambda by 2. This is lambda by 2. So that this complete distance is lambda by 2 plus lambda by 2 will become lambda. Okay. Now, if you take this particle 1, this particle 2, what is the distance between them? This is lambda by 2. Sorry, this is lambda by 4. This one, half of it, lambda by 4. And again, you have to move lambda by 4 plus lambda by 4. So what is the minimum distance between them? Lambda by 2. There is no other, there is other possibility also, but this one is the minimum one. If you disturb this lambda by 2, let's say you have considered this particle and this particle. Now they do not have any same speed because the amplitude has been changed for this particular time. Got it? So the particle which moves with the same speed, the minimum distance between them will be lambda by 2, the minimum one. Although these two particles are moving also with the same, they have same direction of velocity, but the distance is increased. This is not the minimum one. The minimum one is the lambda by 2. But if it is said in the question that the same, not same speed, same velocity, then what is the minimum distance? Then the minimum distance will become lambda. Got it? Then the minimum distance will become lambda. Clear है सभी को? Everyone? Any kind of doubt in this question? You can ask anytime. Now, this one, you need to solve this. A sine wave is traveling in a medium. A particular particle has zero displacement at a certain instant, which means that particular particle is at mean position. The particle closest to it, closest मतलब जो सबसे नजदीक है, to it having zero displacement is at a distance of, which means इसका कोई भाई भाई है क्या जो सेम डिस्टेंस पे हो, जीरो डिस्प्लेसमेंट पे हो. तो what is the distance between these two brothers or these two particles? In the previous question, the distance, minimum distance between two particles has been asked which has same velocity, same speed, sorry. But now the minimum distance has been asked between two particles which have the same displacement. So you can easily say this particle is at zero displacement, this particle has zero displacement. Don't, you do not need to consider any mathematical equation. The particle which is present at the origin line, which is connecting to the origin, or you can say the mean position, that particles having zero amplitude. And let me ask you, if I consider a particle here, second one is here, third one is here, fourth one is here. Now you tell me that what particle has zero displacement? What particle has zero displacement? Is this particle 1, 2, 3 or 4? Tell me, everyone. Student of JNV Ramnagar, tell me. Particle 1 having zero displacement, particle 2 is having zero displacement, or particle 3 is having zero displacement, or particle 4. Multiple options could be there. So it is easy to observe that this is the main line from where we measure the displacement. So this particular particle has a displacement, something, maximum displacement. This particle 2 is at mean position, which means it does not have any displacement. It does not displace from the mean position. So the value of displacement is 0 here. Same way में this particle 4. Now, this particle 2 के closest particle कौन है? Which has zero displacement? This particle only, particle number 4. So we can say that the minimum distance minimum distance between two particles closest to each other having zero displacement is lambda by 2. So if anyone has any kind of doubt in this question, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive in the lecture. If anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being connected. Thank you so much.